Hi friends, welcome to Mygovtrack channel, and today we are going to discuss some previous year questions from fluid mechanics. This will be useful for your SSC JE 2019 exam as well as MAHAGENCO exam. Okay, so without wasting much time, directly we'll start the questions. So coming to first question, the first question is mass density of a liquid is given by. Okay, so this question was asked in SSC JE 2007. So we'll cover the questions from 2007 to 2018. Okay, so the first is what they're asking, the mass density is given by. So we know what is mass density. It is denoted by rho, and the formula for that is mass per unit volume. Okay, so the answer is option A. Okay, option A is the correct answer, and what is the unit of mass density? It's a kg per meter cube. Okay, remember that mass density is mass per unit volume and the unit is kg per meter cube. So the correct answer for this question is option A. Coming to next question, the bulk modulus of elasticity. Okay, so they're asking option A is does not increases with increasing pressure, increases with the pressure. Option C, it's large when the fluid is more compressible. Option D is independent of pressure and viscosity. Okay, so we know that the bulk modulus of elasticity is denoted by K, and K is directly proportional to what? P, that is pressure. So if K is increases, if pressure is increases, then bulk modulus of elasticity also increases. So the correct answer for this question is option B. Okay, and bulk modulus of elasticity of isothermal process is pressure is equal to pressure P, and for adiabatic process it is written as K for adiabatic is equal to gamma into P. Keep in mind that. So for this question the correct answer is option B. When we increase the pressure, bulk modulus also increases, and the formula for bulk modulus is what? The change in pressure to the volumetric strain, so dV upon V. Okay, this is the formula of bulk modulus of elasticity. Coming to next question, the rise, or question number 3, the rise or fall of a head H in a capillary tube of a diameter D and a liquid surface tension sigma and the specific weight W is equal to what? So they are asking what is the formula for head. Okay, we know in the capillary concept the formula for head is H is equal to 4 sigma cos theta divided by rho g d. Okay, rho g is nothing but the specific weight. We can write as a W also. This is the specific weight. So they have not mentioned the theta value. Okay, so we can take it as a 0, assuming the clean surface. So cos 0 is equal to 1, and when cos 0 is equal to 1, then what will be left behind? So 4 sigma upon W d. 4 sigma upon W d. The correct answer will be option A, 4 sigma upon W d. W is nothing but the specific weight. We can write as a rho into g, density into space, gravity, acceleration due to gravity. Okay, the correct answer is option A, 4 sigma upon W d. This is the formula for rise or fall of head. Coming to next question, question number 4. So as per law of fluid friction, for steady streamline flow, the frictional resistance, okay, they are asking a frictional resistance. So option A is varies proportionality to functional pressure. Option B varies in inversely proportional to the pressure. Option C does not depend on pressure. Option D first increases then decreases. Okay, the correct answer for this is option C. As per law of fluid friction, for steady streamline flow, the frictional resistance, this is the frictional resistance. So frictional resistance is not depend on the pressure. So it is not depend on pressure, because frictional resistance is depend only on the viscosity. Okay, viscosity is the main factor to decide the frictional resistance. If the viscosity is more, then frictional resistance will be more. That's why the frictional resistance does not depend on pressure. The correct answer for this question is option C. It does not depend upon the pressure. Okay, coming to next question. Question number 5. An ideal flow of any fluid must satisfy. Okay, so ideal fluid must satisfy, correct answer for this question is option D. It must satisfy the continuity equation, that is A1 V1 is equal to A2 V2, means area into velocity, that's flow rate should be constant. Okay, this is the continuity equation. So an ideal flow of any fluid must satisfy continuity equation. The correct answer is option D. Next question. Question number 6. The flow which neglects the changes in transverse direction is known as, this is very simple, it neglects the changes in transverse direction, means what, it is a one dimensional flow. The correct answer for this question is option A. If it neglects the any changes in transverse direction, then it should be a one direction full flow only. Okay, correct answer is option A. Question number 7. The property of a fluid which enables it to resist resistance tensile stresses is known as what? So if we know the forces of attraction between the molecules, okay, the forces of attraction between the molecules of same type, okay, so that property is known as what? Cohesion. Okay, that's why the property of a fluid which enables it to resistance tensile stresses, so it opposes tensile stress, it resists the tensile stresses, that's why it is that property is known as cohesion. The correct answer for this question is option C, cohesion. Coming to next question, question number 8. They're asking the kinematic viscosity is equal to what? So if you know the formula, kinematic viscosity is denoted by nu. Nu is equal to what? Dynamic viscosity, that is mu upon density rho. The formula for kinematic viscosity is nu is equal to mu upon rho, the ratio of dynamic viscosity to the density. The correct answer for this question is option A, dynamic viscosity per unit density. Okay, and what is the unit of kinematic viscosity? The unit of kinematic viscosity is meter square per second. Okay, this is the SI unit, and in CGS it's a Stoke. Okay, keep in mind. And what is the unit of dynamic viscosity? The unit of dynamic viscosity in SI is Newton second per meter square. We can call it as a Pascal second. And in CGS it is written as dyne second per centimeter square. Okay, next question. Question number 9. Which one of the following is the bulk modulus K of a fluid? Okay, so option A, dP upon rho d rho. So just now we saw that the bulk modulus formula, what is the formula? K is equal to change in pressure dP, it's not rho, it's P, dP upon d rho upon rho. Okay, this is the formula. So by looking at the options, you can see the correct answer for this question is option D, dP upon rho upon rho. Okay, so rho into dP upon d rho, this is the correct answer for this question. Coming to next question, question number 10. Pseudoplastic substances are non-Newtonian fluids for which, okay, for which option A is what? Dynamic viscosity increases as the rate of shear increases. So if you know, in case of pseudoplastic, okay, the dynamic viscosity decreases at the rate of shear stress increases. So if you know curve for pseudoplastic is, this is tau and this is du upon dy. So the curve for pseudoplastic is like this, downward. So the correct answer for this is when dynamic viscosity decreases and as the rate of shear stress increases. So these are two inversely proportional in case of pseudoplastic, because pseudoplastic is a non-Newtonian fluid, and in case of a Newtonian fluid it's a directly proportional. Okay, when the dynamic viscosity increases, the rate of shear strain also increases in case of Newtonian fluid, but it is written as a pseudoplastic, so it's inversely proportional. The correct answer for this question is option D. Next question, question number 11. an ideal fluid has what? Option A has no viscosity, option B satisfies the relation PV is equal to RT, so option C obeys the Newton law of viscosity, and option D is both incompressible and non-viscous. Okay, so if you know, ideal fluid is a non-viscous, incompressible, it has no zero surface tension. Okay, these are the properties of ideal fluid. So as per the options, option A is correct. Okay, because it has a no viscosity, that's the correct, and option D is also correct. So option D is written as is both incompressible and non-viscous. Okay, so it is a combination of option A and option D. The correct answer for this is option D. Okay, an ideal fluid is both incompressible and non-viscous also. Next question, question number 12. Pascal second is the unit of what? Just now I told you Pascal second, it's the unit of mu, that is dynamic viscosity, Newton second per meter square. We can write as Pascal in place of Newton per meter square, nothing but Pascal and second. So it is the unit of dynamic viscosity. The correct answer for this is option C. Pascal second is the unit of dynamic viscosity. Question number 13. When a fluid is in motion, the pressure at a point is same in all directions, then the fluid is known as what? Okay, so it is an ideal fluid which is incompressible, irrotational and non-viscous. Okay, which is used in a continuity equation as well as in Bernoulli's equation. Hence, see, when the fluid is in motion, then the pressure at a point is same in all the direction. Okay, so that's why that fluid is known as ideal fluid. Okay, the correct answer for this question is option C, ideal fluid. Next question, question number 14. Mercury does not wet the glass surface. This property of mercury is because of what? Option A, adhesion, option B, cohesion, option C, surface tension, option D, viscosity. So the correct answer for this question is option B, cohesion. Why? Because high cohesive forces among the molecules of mercury, okay, and that's why they dominate over the adhesive forces. Hence mercury does not wet the glass surface. Okay, the correct answer for this question is option B, cohesion. So because of cohesion, mercury does not wet the glass surface. Question number 15. Here it is given as the velocity distribution for the flow over a flat plate. Okay, so u is equal to y minus y square. U is given as y minus y square. U is the velocity and y is the distance, y meter above the plate. Okay, what is the shear stress value? So they are asking the shear stress, means tau is equal to what? At y, and they have given y is equal to 0.15 meter also, and the dynamic viscosity for the fluid is, they have given the dynamic viscosity also, so 0.8 poise. It's in CGS unit. So what is the formula for that to find out the shear stress? So shear stress tau is equal to mu du upon dy. We can easily find out that value of tau, that is shear stress. We can it's given as a 8 poise. Okay, so 8 poise we can convert into Newton second per meter square, that is 8 into 10 raised to minus 1 Newton second per meter square, and du upon dy, we can find out the du upon dy by differentiating u with respect to y. So y minus y square, nothing, the differentiation of du upon dy is nothing but 1 minus 2y. So we can put the value of y as a 0.15 and we can find out the value of shear stress. So the correct answer for this question is, after calculations, option C will be your right answer, 0.56 Newton per meter square. Okay, coming to next question, question number 16. A hydrometer is used to determine what? Hydrometer is an instrument that is used to determine specific gravity. We can call it as a relative density also. So the correct answer for this question is option C. Hydrometer is used to determine the specific gravity. Specific gravity is nothing but density of a fluid to the density of standard liquid, that is water. Okay, next question, question number 17. Pressure intensity inside the water droplet is what? They're asking the pressure intensity inside the water droplet. So the formula for that is P is equal to 4 sigma upon D, and the pressure intensity inside the soap bubble is nothing but P is equal to 8 sigma upon D. Okay, and what else? The pressure intensity inside the jet, water jet, is nothing but P is equal to 2 sigma upon D. So keep in mind these three formulas. Okay, pressure intensity for water droplets is 4 sigma upon D. Soap bubble, it's 8 sigma upon D, because there are 2 layers of soap and soap bubble, and in water jet the formula is P is equal to 2 sigma upon D. Okay, and for this question the correct answer is option C. Next question, question number 18. So they're asking 1 stoke is equal to what? Okay, question number 18. So 1 stoke is nothing, stoke is the CGS unit of what? Kinematic viscosity, and 1 stoke is nothing but 10 raised to minus 4 meter square per second. Okay, this is the value of 1 stoke. So the correct answer for this question is 1 centimeter square per second in CGS. Okay, we can convert meter square to centimeter square. So the correct answer is 1 centimeter square per second. Option A is the correct answer. After that, question number 19, the dimensions of surface tension. We know the formula of surface tension. What is surface tension? Is denoted by sigma. Surface tension is nothing but the force per unit length. And what is the dimension of force? It is mlt minus 2 to the length. So LL get cancelled. The remaining is mt minus 2. So the correct answer for this question is option B, m1l0 t minus 2. Right? Next question. Question number 20. To prevent oscillations of meniscus, the length of the connecting tubes should be what? Okay. So if you know, when the capillary tube is dipped in some liquid, the liquid will rise and reach to the top due to surface tension. Okay, and if the connecting tubes are small in length, then there will be no oscillation of the meniscus, as the viscous forces will dampen out, and then oscillation at the top edge. So the correct answer for this question is small. Okay, the option C is the correct answer. To prevent the oscillations, the connecting tube, or we can say the capillary, should be small. Option C is the correct answer. Question number 21. Here it is asking the height, that is the expression for the capillary rise, is given by what? Okay, so we know the expression is 4 sigma cos theta upon rho GD. Okay, the capillary rise H is equal to what? 4 sigma cos theta upon rho GD. This is nothing but specific weight. We can write as a W also. The correct answer for this question is option B. Next question. What torque in Newton meter is required to give 3 meter cube per second of water a moment of momentum, so that it has a tangential velocity of 3 meter per second at a distance of 1.8 meter from the axis? Okay, so what they have given, first tangential velocity, it's a 3 meter per second. Okay, the C, V equal to what? 3 meter per second. This is the tangential velocity. After that, they have given the discharge is the 3 meter cube per second. Okay, after that, distance is nothing but 1 r equal to 1.8 meter, right? And they're asking what? The torque. Torque is torque or moment of momentum. Okay, see, torque is equal to rho q v into r. Okay, formula for this torque is rho q v into r, because moment of momentum they are asking. Okay, first momentum is nothing but rho q into v. Rho q into v is the first momentum, and moment of momentum is nothing but rho q v into r. So the after multiplying this all, the correct answer will be 16200 Newton meter. Option A will be your correct answer after calculations. Question number 23. 1 poise is equivalent to what? Okay, 1 poise is the CGS unit for dynamic viscosity. Okay, and if you know 1 poise is equal to 10 raised to minus 1 Newton second per meter square. Okay, and now they are asking in gram centimeter second. Okay, so the correct answer for this is 0.1 kg per meter square per meter second, or we can write as a 1 gram per centimeter second. Okay, so the correct answer for this is option B. Option B will be your right answer, 1 gram per centimeter second. Question number 24. The rate of change of moment of momentum represents what? Okay, just now we saw the formula. The rate of change of moment of momentum is nothing but the torque applied by the fluid. Okay, see the rate force. What is force? Force is the rate of change of momentum. Okay, and hence the rate of change of momentum about a point is known as torque. Torque is nothing but what? Force into distance only, right? Torque is nothing but force into distance only. Force nothing but moment of momentum. So the rate of change of momentum is nothing but force, and the moment of momentum is nothing but the torque. So the correct answer for this is option C. The rate of change of momentum represents the torque applied by the fluid. Okay, so guys, these are your some important previous year's questions which is asked in SSC exam. So we'll discuss some other previous year questions from different topics also. So if you have any doubts, or if you want any explanations from these questions, so you can join our WhatsApp group. The link is in description, and you can ask your doubts there. So we'll try to give the best explanation over there, and we'll provide next parts soon. And so I will cover the most important questions and previous year questions which was asked in SSC JE. So that questions will be useful for your MAHAGENCO exam as well as SSC JE 2019 exam. And if you like this video, then please like, share and subscribe to my Mygovtrack channel. And thank you so much for watching this video.